Now in triangle ABC, AP to PM is 2 to 1, BM equals MC. This makes it the centroid of the triangle. Now we have to find the coordinates of P given that OA is I plus J, OB is 2I plus 5J, and OC is 6I plus 3J. Now to do that, first of all, we need to find out what AC is. Now we know that OA plus AC equals OC. Therefore, AC must equal OC minus OA. AC we're given is 6I plus 3J, and OA is I plus J, which gives me 5I plus 2J. Now we've got AC. I want to find what BC is. Now to do that, I know that OB plus BC, OB plus BC must equal OC. So therefore the BC must equal OC minus OB, which equals 6I plus 3J minus OB, which is this one, 2I plus 5J, and that's going to give me 4I and 3 minus 5 minus 2J. Now seeing we've got BC, we need to find out what MC is, and MC is half of BC, so MC is a half of 4I minus 2J, which of course is 2I minus J. That one. Now, in this triangle here then, I need to find out what AM is. So we know that AM must plus MC, AM plus MC must equal AC. So we know that AM must equal AC minus MC. I'll go over here now. So AM must equal AC, we just worked out over here, as 5I plus 2J. Now, and MC is this one here, minus 2I minus J. And that becomes 3I plus 3J. So it's AM. It's now AP. So AP must be 2/3 of AM, which gives me 2I plus 2J. But we need to know what OP is to work out what it is, and we can see that OP must be equal to OA plus AP. And OA we know is I plus J. And this one is 2I plus 2J, which gives me 3I plus 3J. Now this is the position vector OP. Being the position vector, then the coordinates of P must be 3 there, 3, 3. And that's the coordinates of the centroid worked out using vector methods. In the second example, we're going to work out a formula for the area of this triangle. Now to do that, I'm going to use the fact that the cos of theta, if you recall, is equal to the scalar product over the magnitude. So if we go to this triangle then, right angle triangle, we can see that the cos of theta must be B dot C, like that. So now I can work out what H is in terms of these, because using the fact that from Pythagoras being a right angle triangle, we can see that H squared will be equal to B C all squared minus B dot C all squared. So H is equal to the square root of all this. And if you recall, the area of a triangle is equal to the magnitude, which is B, or half of B, C, sine of theta. And from that triangle over there, we can see that the sine of theta is H over this. So these go out, and that's equal to a half of the square root of this. All squared minus B dot C all squared. Right, here's an example using this triangle here with the various coordinates 1, 4, 7, 6 and 3, 1. We need to find the area of that triangle. First of all, we need to find the vector B. So the vector B is equal to 7 take away 1 I plus 6 take away 4 J, which of course gives me 6I plus 2J. The vector C is equal to 3 take away 1I plus 1 take away 4J, which gives me 2I minus 3J. Now all that remains now is to put it into the formula. So first of all, we need what the scalar is. So it's going to be 6I plus 2J times 2I minus 3J. And that's going to give me 12. And 2 times minus 3 is minus 6, which gives me 6. Now to get the modulus of B is simply going to be square root of, that's 36 plus 4, which is square root of 40. The modulus of C, or the magnitude of C, is equal to this one squared, which is 4, plus this one squared, 9. That's going to give me the square root of 13. Right, so the area equals 1/2 square root of these two multiplied together and squared, which will just give me 40 times 13, and minus 36, or 6 squared, 36. And that will give me, check my maths, half of, just gives me 11. And you work it all out on your calculator.